Greetings. I hope this finds you well. And we are going to go over how to write formulas for ionic compounds. We covered the covalent compounds, which are nonmetals only. This one is a metal and a nonmetal. Okay, so when I talk about binary compounds and tertiary, binary, like a bicycle has two wheels, there's two elements in that compound. Tertiary means that there's three elements. Okay, so a formula is written like this, where you have the two elements or more that's forming the compound, and it tells you how many atoms there are of each element. And we write them together to show that they are bonded together. Okay, ionic compounds are formed from metals and from nonmetals. I'll make sure you know which those are, which are nonmetals, and all the rest are metals. But this little corner up here, those are all the nonmetals. Okay, so something to know about metals. They lose electrons, they become positive. They lose all of their valence electrons. For example, magnesium. Magnesium is right here. And it has two valence electrons because it is in group 2A. All these elements right here have two valence electrons. So when it loses those, when it loses two, it will become positively charged. And we write this with a little superscript. Nonmetals, kind of the opposite. They tend to gain electrons, and they need a gain enough to make 8. So first of all, let's see how many they actually have. So group 6A would have 6 valence electrons. So if we're talking about oxygen, it has 6, and so it's going to gain 2 more to make 8. So it's gaining negative electrons, and so its charge would be -2. Okay, so if I put these two together in a compound, then I have -2 and a +2. They balance each other out, and so that forms the compound. And you'd have one of each. Okay, so what if the charges do not balance? You have let's say a +3 and a -3. You don't have that. You have something different. Okay, so let's try this one. We're going to do the crisscross method, and so I'd have +2 for magnesium and -3 for my nitrogen. Okay, so I'm going to crisscross. I'm going to bring the 2 down, and I'm going to bring the 3 down. Not the positive, not the negative. I'll bring it down to 2, and I'm going to bring down a 3. And so now I have magnesium 3 and N2. So 2 atoms, 3 atoms. So what's happening is if I multiply these, I have 3 atoms of 2 plus each. That gives me 6 plus. And I have 2 of 3 negative each. I have 6 negative. So now by adding atoms to each one, now I have a balanced charges to equal 0, and that's what I want. Okay, now just so you know, when I say nitride, I mean nitrogen. I change the ending because it's in a compound. Okay, here's some examples. So chlorine would change to chloride. So when you're looking for this element, you're not going to find nitride on the periodic table. You're going to find the closest thing. So oxide, you're going to look for oxygen. Iodine. And so if it says iodide, look for iodine. Okay, let's try some. This is how I want you to do it on a quiz or a test. When I say show your work, I mean show me the charges like this, and this is your final answer. Okay, so aluminum, I'm going to find Al. Nitride, I'll look for nitrogen. Okay, and I see that nitrogen is -3, and this is +3. So this is showing your work, showing the charges. Crisscross, actually you don't need a crisscross on this one because they equal. Okay, so I'm just going to write Al, and I'm going to write N. So I'd have one of each, but I don't write the ones. Final answer. Okay, let's try this one. Sodium oxide, I'm going to have Na. It's going to be a 1 plus. I'm going to have oxide, which is oxygen, 2 minus. Okay, they do not equal out, so I'm going to take and I'm going to crisscross these numbers. The 1 here and the 2 there. Not the negative, not the positive. Let's rewrite it in A with a 2 and O, and I don't write the 1. Okay, and so that is my final answer. Okay, sometimes the name has a Roman numeral in it. If you see a Roman numeral, it just means that it's giving you the charge, because for some reason it cannot be determined on the periodic table, or it may have several different charges possible, and so it will tell you what it is. In this case, do not use the one on the periodic table. For example, if you're looking at the iron, Fe, so I have here, it's in group 8b, but that cannot be. There's a few quirks on the periodic table, and this is one. These do not have 8 valence electrons, and so I have to go by the charge that it will give me in the problem. If you don't know your Roman numerals, here they are from 1 to 10. So 1, 2, 3, that would be 4, 5, 6. Okay, so let's try this. So I've got iron bromide, and it's specifically iron 2 bromide. So that means this gives me this charge right here, the 2 plus. So again, I'm going to crisscross. 1 comes down here, 2 comes down here. That would be my final answer. Okay, let's try some more. Okay, IV means 4, and so I'm going to have Pb is lead, and I'm going to have 4 positive. I'm going to have chlorine, which is in group 7, so 7 minus 8 gives me negative 1. Okay, I'm going to crisscross. I have 4 here and 1 there. Let's rewrite it, and I'm going to have Pb, 1, I don't write the 1, Cl, 4, final answer. Okay, let's try another one. Okay, so I've got Pb, the 2 tells me it's a 2 positive. The Cl is still negative 1, and now I have PbCl2, final answer. Okay, on this one, okay, I've got a 4. Okay, so I'm going to have Pb, 4 plus, and oxide, O, negative 2. In this case, I'm going to bring the 4 down. I'm going to bring the 2 down. So now I have Pb2O4. However, these right here, I can divide them. I can make them smaller. So I divide both of these by 2, then I'm going to have the lowest ratio possible. So Pb1O2. So check to see, is it divisible by 2 or by 3? And then you have to divide it. Okay, ternary ones, those are the ones that have polyatomic ions. So these act as a unit and you cannot separate those. Okay, let's see what I mean by that. Well, first of all, let's see where the polyatomic ions are. They are on your ion sheet, so let's try to do some. Okay, so I'm going to find carbonate on the ion sheet. Okay, so this is the ion sheet. Everybody should have one of these. And I am going to look down, I'm going to look for the polyatomic ions. Okay, what I want you to do is pause the video, and I want you to highlight or put a star beside all the ones that I have starred. Okay, so for example here, there's only very few ones that have a positive charge. Okay, so if you would please star these or highlight them or color them in. And these are the ones that, not the only ones we use, but those are the most frequent ones we're going to use. Okay, so acetate, there's 2 different ways to write it. One gives you a little more information about what the structure is. Okay, let's come over here and make sure that you star these. Okay, so carbonate, that's the one we were looking for. Okay, I've got it in Spanish, I've got it in English, and then here is the unit. This is the polyatomic ion. And this has a certain formula. Do not change these little numbers here. Do not change them. Write them exactly like they are. Don't disappear them. Don't change them. Okay. Okay, let's do the ones on the back. Here's hydroxide, phosphate. Notice that it's a little bit different. One has a 3, one has a 4. Thiocyanate. And let's do these over here. Sulfite. So go ahead and mark those. Okay, so let's try these. They all have zinc in them, so zinc 2+. If you'll notice the ending IDE, this means it's just nitrogen. The ITE and the ATE, if you look at the ion sheet, right here, I have nitrite and I have nitrate. So you just have to look for the name and it'll tell you what the two formulas are. So I'm going to put these together. I have a 2 and I have a 3. So Zn gets the 3 and N gets the 2. Okay, on this one I have a -1, so I'm going to crisscross. So Zn gets the 1, I don't write it. And then NO2 gets a 2. So I have another 2. I'm going to put this in parentheses and then my 2 outside. Okay, zinc, still have a 1. I have, in this case, NO3, and I have a 2. So, notice the difference. Nitride, nitrite, nitrate. Can get confusing, but it just pay attention to the details. Alright, let's try this one. Okay, so we're back, and hopefully you have done these and give you a little bit of chance of practice. Okay, so I have a 3 and a 2. That means the 3 comes down, the 2 comes down here. So I have Fe, a 2, and then I have SO4 with a 3. Again, do not change that 4, put a 3 here. Okay, I have 2 and I have 1, so crisscross, and I would get Ca with a 1, and then I would get Cn with a 2. And I have to put a parentheses, then the 2. Okay, I've got gold 3, and I know it's 3 because it says right here. Use that instead of what's on the periodic table. So Au with the 2, and then I have CO3, which I put in parentheses, and because I'm bringing down a 3. If this were a 1, I would not need the parentheses. And so these are my final answers. I hope this helps, and I'll see you next time.